Hey guys, how are you all? I hope you all are doing well. We have started lecture series on a different competitive exam like NET SET Gate and other competitive exam. Within that, I already uploaded plenty of the videos on my channel. So if you wanted to see this video, if you are excited to solve the previous year question from NET SET Gate and other competitive exam, you may check it into my playlist. Refer this video for understanding. And even after if you have any doubt, difficulty, let me know in comment section. I will come up with the separate videos for you all. So in my today's video, I'm going to explain to you all one of the question from linear algebra GATE latest question paper, which is like 2020. Okay. So we have to find out the dimension of our vector space. Okay. Dimension of subspace. So we have given two subspace and we have to find out dimension of their addition. Now let's get started our today's solution. We'll go through the detailed understanding of question and solution. Here in our question we have given consider the subspace. Okay, so we have given subspace w1 and w2. Okay, so we have two subspace here, w1 and w2, and w1 subspace, it says that it contain x1 x2 x3, three of these elements which is from R3. Okay, and x1 can be written as x2 plus 2 times x3. Okay, and similarly for w2, x1 x2 x3 from R3 and x1 written as 3x2 plus 2x3. So x1 written as 3x2 plus 2x3 of R3. Okay, so these two subspace from R3, then we have to find out the value for dimension of W1 plus W2. Okay, that means dimension of first subspace plus second subspace. Okay, so we have to find out the dimension. Now let's get start solution. We'll go through the detailed understanding of our solution with their respective results. In our question, we have given the value for W1 and the value for W2. Okay. For finding the dimension of a W1 plus W2, we have to work for the dimension of a W1 separately, and we have to work for the dimension of a W2 separately. Okay, so using subspace W1, we are going to find out the dimension for W1. Okay, so we have W1 over here. So how can we find out the dimension? So dimension of a W1, let me write the dimension. X1, we have X2 and X3. Okay, three of these variable we have here from R3, and x1 can be written as x2 plus 2 times x3. Okay, x2 plus 2 times x3, this is the value for x1. Okay, and x1 x2 x3 which is from R3. Okay, we have to find out the dimension for W1 here. So dimension of a vector subspace, what it says that dimension of subspace means the number of linearly independent vectors which present in our subspace. Okay, so we have subspace W1. Okay, x1 x2 x3 from R3. So we have to find out the linearly independent vectors. Okay, so how many linearly independent conditions are possible for our subspace? Okay, now here how many times we can write their linearly independent condition? Okay, so first here x1 is equal to x2 plus 2 times x3. Okay, this equation is given. So for finding the value for x1, we need x2 and x3. Okay, so we have two linearly independent vector here. Okay, x2 and x3. Okay, so number of linearly independent vector which available here in a subspace W1 is the number of here 2. Okay, that means for finding the value for one variable, we need two different variable here. Okay, so these are the two different conditions. Okay, two conditions for linearly independent condition for dimension of a W1. Okay, and when we have number of linearly independent condition, then we say that the number of linearly independent condition is a dimension of our given subspace. Okay, so W1 is having two linearly independent vectors here. Okay, so using this we can generate two linearly independent conditions. So dimension of W1, okay, dimension of a W1, how many number of linearly independent conditions? 2. Okay, so I got the number of linearly independent conditions using the W1, subspace W1, it is a 2. Okay, so I can write here a number of linearly independent condition is a 2. So dimension of a W1 which is a 2. Okay, now we want the dimension of a W2. Okay, so how can we find the dimension of a W2? So W2, we are having the values in a W2 is like x2, x1, x2, x3 from R3. Okay, and x1 can be written as 3x2 plus 2x3. Now see that how many linearly independent conditions are here. Linearly independent condition in our subspace W2 means for finding the value for x1, how many condition we have to follow here in our subspace W2. Okay, so we need to find out the values for x2 and x3. Okay, these are the two linearly independent condition for finding the value of x1. So dimension of W2, similarly we write x2 and for finding dimension of W2, x2 and x3. Okay, x2 and x3, these are the two linearly independent vector. Okay, these are the two linearly independent vectors. So we write dimension of W2, which is a 2. Okay, so dimension of a W1, which is a 2, and dimension of a W2, which is also 2. Okay, I hope you all have understood how can we find the dimension of a 2 vector space. Okay, now for finding the dimension of a W1 plus W2, we have to follow one standard result over here. So dimension of a W1 plus W2, it says that dimension of a W1 plus dimension of a W2 minus dimension of a W1 intersection W2. So we have to follow this result over here. So here we can see that standard result that is applicable here for finding their dimension. So for finding the dimension, we know here dimension of W1 plus W2, which is the dimension of W1 plus dimension of W2 minus dimension of their intersection. Okay, now it's quite challenging to find out dimension of a W1 intersection W2, but we'll see it later. First of all, see the dimension of W1 and W2. Okay, so dimension of W1 is a 2, dimension of W2 is a 2. Okay, and minus, find out their intersection. Now we want the intersection for dimension of W1 intersection W2. Okay, W1 intersection W2. Okay, I want the dimension for this one. So for finding the value for dimension of W1 intersection W2 means we have to take the vector space from subspace from W1 and W2, subspace W1 and W2. We have to merge it together and we have to find their intersection. Okay, the common value which is coming from dimension of W1 and dimension of W2, which is there in a intersection of dimension of W1 intersection W2. Okay, now here we can see the value for x1 it is here in a W1 and value for x2 it is here in a W2. Okay, so for finding the dimension of W1 intersection W2, so we have to equate these values. Okay, once we equate this value, we'll get the linearly independent condition. Okay, so if x1 which is equal to x2 plus 2x3 and x1 is equal to 3x2 plus 2x3, so I can write this one as x1 which is equal to x1. Okay, so x1 which is equal to x1 I written here. Okay, so for finding the dimension of W1 intersection W2, so this x1 I written here x2 plus 2x3, so x2 plus 2 times x3, which is equal to next x1 which is from the subspace of W2, 3x2 plus 2x3. So 3x2 plus 2x3. Okay, so take x2 term together and x3 term together. Okay, so plus 2x3 will get cancelled. So x2 which is equal to 3x2. Okay, x2 which is equal to 3x2. So take this one to other side. So 3x2 minus x2, 3x2 minus x2, which is x2 which is equal to 0. Okay, to x2 which is equal to 0, 0. This means x2 gives value 0. Okay, so I got the value for x2 which is a 0. Okay, so what is the value for x2? I got it here 0. So if x2 is a 0, okay, if x2 is a 0 here, okay, so apply this x2 0 in our subspace. So if x2 0, we'll get the x1 which is equal to 2x3. Okay, so I got the value for x2 0, then x1 which is equal to 2x3. Okay, and there is no any chance to figure it out the value for x3. Okay, so for that x3 will keep it remain it same. Okay, we make it same. So now I got the value for x2 0, x1 is a 2x3 and x3 remain x3. Okay, so dimension of a vector space means number of linearly independent condition, how much it is coming inside. Okay, so the value for x1, x2 and x3. So within that I got the value for x1 itself x1 which is equal to 2 times x3. Okay, so which is a 2x3. Okay, x2 which is a 0 and x3 remain as it is. Okay, so here we can see, here we all can see I written dimension of W1 plus W2 here. For your detailed understanding, I written this all over solution over here. Okay, x2 I got it 0 for finding their intersection. Okay, so other part is, it is quite easy for finding the intersection between two subspace. It is quite bit confusing for you all. Okay, but nothing is difficult. So if x1 is this, x1 is this, then we write their intersection this, which is equal to this. Okay, if this is equal to this, I got the x2 0. Then if x2 0, then x2 0, put it here. If x2 0, x2 0, then x1 is equal to 2 times x3. Will get only the one condition over here. Okay, so value for x1 I got the 2, x3, x2 I got the 0, and x3 which is a x3 itself. Okay, now I want the dimension of w1 intersection w2. Okay, so we have only the one li condition, which is a middle one. Okay, which is a 0. So dimension of w1 intersection w2, which is a 1. Okay, okay, so I got the dimension of w1 is 2, w2 is 2, and their intersection which is 1. Now apply these values to our standard result. Okay, so dimension of w1 plus w2, it says that dimension of w1 which is 2, w2 which is 2, minus their intersection is 1. Okay, so we got the 4 minus 1, which is a 3. Okay, so dimension of w1 intersection w2, which is a 3, which is a required fill in the blank. Okay, I hope this is very much easy question. Nothing is difficult over here. Okay, you have understood everything easily here. So even after, if you found anything difficult on my solution question, let me know in comment section. I will come up with some other videos. Okay, so thank you everyone. Thank you for my today's lecture.